Hello students, in the last session we completed altogether 16 sums. Those sums were mainly related to the differentiation concept and then the average velocity, some graphical based sums, right? So those were the 16 sums that we saw. As we have already told, the toughness level for the IIT JEE examination will be like one step ahead of the NEET examination. So the mathematical solving was trickier. You should be clear with all the different mathematical solving that I did, but the concept is going to be the same, right? Anyway, in this session, we'll do the next 8 to 9 sums. These sums will also be related towards the graph and then the velocity, right? Fine. So let's jump into the next question. That's going to be the 17th one. So in this question, they have given you a body travels 102.5 meters in n seconds, right? So they have given you the first n seconds in which it has traveled the distance of 102.5, okay, right? So then, and 115 meters in n plus 2 seconds, the acceleration is. So I just need to get the acceleration, right? So this is not a free fall case. So if it was like a body that was dropped down, I will use this formula S, which is equal to U minus half G to N minus 1, right? There I just got the negative sign because it was acceleration was actually acting downwards. That's not going to be the case over here. Here it's just a normal acceleration, right? So the formula that we need over here is S equals U. Instead of negative, you'll get the positive plus half A to N minus 1, right? You should be clear with this formula. I've told you to memorize this one in the theory part, right? So there you would have got like G if it was gravity, therefore I'll get this negative sign. But in this situation, that's going to be positive because I've just plugged it in A, acceleration, right? So you have to be clear with this question. So here they have given us a body travels 102.5 meters in n seconds. So in the first n seconds, it has traveled a distance of 102.5 meters. So here I'll substitute like n, right? Next, in the n plus 2 seconds, okay, it has traveled a distance of 115 meters. So in the next case, I would have substituted n plus 2 for this n, okay? For the first condition, that's going to be 102.5, and for the second case, it's going to be 115. So if I do, yeah, if I do the rearrangement accordingly, I'll end up getting the answer, isn't it, right? So that's how I have to do this one. Let me solve this question. Well, first, let me frame the first equation. That's going to be something like this: 102.5, which will be equal to the initial velocity u plus half a to n minus 1, isn't it? To n minus 1. So this is the first equation that is needed. And the next equation is going to be, yeah, something like this. 115, 115, that's going to get you u plus half a. Instead of 2n minus 1, I have to plug it to n plus 2, right? So that will give me 2n plus 4, yeah, 2n plus 4, negative 1. I do not want to put the bracket, I've just done the multiplication, minus 1, right? So here I'll have to solve these two equations. This is going to be the first equation. This one will be the second equation, isn't it? If I have to solve these two equations, how would I be able to do it? If there wasn't any u into it, yeah, it would have been easy, right? I would take the ratios and I'll get the answer. But in this case, let me rearrange it. So you would have got u minus this entire term, 102.5 minus this entire term, which will be equal to u. Same way here, 115 minus this entire term will be equal to u, right? If that's going to be the case, then I'll be able to equate this first and then the second equation because you'll have the common left hand side, which is going to be the u, right? It has to be clear. Simple stuff. I've just rearranged it and I equated it. That's it. So in the above situation, here you would have got 102.5 negative of half a, negative of half a to n minus 1, that will give you 115 minus half a to n plus 3. Okay, fine. Now just do the rearrangement and do the solving. That's it. Yeah, let me bring this to the right hand side, left hand side. So I would have got half a, yes, right? Yeah, half a. I'll just factor this half a, then you would have got half a 2n plus 3, okay, negative half 2n minus 1, 2n minus 1, that will give you 115 minus 102.5, negative of 102.5. Next, if I do the subtraction of these two terms, that should have given you 102.5, isn't it? So if it was like 110, that's going to give you 7.5. So 7.5 plus 5, which will give you 12.5. Yeah, right. So the subtraction of this term will give you 12.5. Okay. So on the left hand side, you would have got half a, or let me multiply it on the right hand side, that would have given you 2 over there. So a. Next, if I do the inner multiplication, I've got 2n and then the negative 2n, right? So these two stuff will get cancelled out, right? Yeah, then negative 1, that's going to become positive. So that will give you plus 4. Yes, yes, absolutely. Plus 4. So let me do the solving over here. So before that one, these two, 4, 2 will get cancelled out and you would have got 1, 2 into it. So acceleration A will be equal to 12.5 divided by 2. So if you have to divide this one, you would have got like 6.25 meter per second square, right? 6.25 meter per second square. That's going to be option 2. Fine. You have to be clear with this question. This is a simple one, easy, straightforward one. They have given you the distance traveled in n seconds and they have given you the distance traveled in the n plus 1 seconds, right? We just know the formula straight away. Just generate those two equations with respect to distance traveled in n seconds. So once you get that equation, you know that u is going to be the same. Initial velocity is going to be same for both those conditions. If there wasn't that u, I would have taken division and I'll do it straight away. But in this situation, I'm just going to rearrange it accordingly. Now I'm ready to equate those two equations. Once I equate those two equations, n will get cancelled out. Only parameter that will be left over there will be the acceleration. Just do the solving, you'll get the answer. That's it, finished, right? It has to be clear. Let's move to the next question. This sum is also based on kinematic equation. Let me read the question. A bullet is fired into a fixed target, loses one third of its velocity after traveling 4 centimeter. Got it? So here I've got a gun. I'm just gonna fire it. Once I fire it, it has lost one third of its velocity after traveling a distance of 4 centimeter, which means the leftover velocity will be like 2/3 of the velocity once it has covered a distance of 4 centimeter, right? So that's the first statement. Then they have given us it penetrates further. Okay, so it's going to penetrate further a distance of d into 10 power minus 3 meter before coming to rest. Okay, so this is the further distance after covering the distance of 4 centimeter. Okay, so you have to be clear with this idea. So here they have given you this term further, which means this is the next distance that it's going to cover after this 4 centimeter. Okay, so what they're asking us to find is what will be the value of d for this case. Fine, so I have to consider this d in terms of d into 10 power minus 3 meter. So while doing the solving, I'll generate two equations. First equation will be with respect to this first statement. Got it? The kinematic equation that I will choose will be between velocity and then the displacement. Therefore, I'll choose the third kinematic equation, which will be b square minus u square will be equal to 2as, right? So that's the kinematic equation that I'm going to choose. So with respect to the first one, I'll get the equation straight away. Then for the second equation, that will be the next part of the distance that it's going to travel. That will be between d into 10 power minus 3 meter, right? So here also, I'll just convert it to meter. Therefore, I'll be able to solve it straight away. Got it? So this sum has to be clear. So let me draw the diagram. So here, let us take some target wooden plank or something like that. Okay, so this is going to penetrate, the bullet is going to penetrate this wooden plank or wooden box, whatever it is. So initially, it has covered a distance of 4 centimeter, which is going to be 4 into 10 power minus 2 meter. Let us consider the initial velocity to be v. once it has reached a distance of 4 centimeter, it will lose one third of its velocity. So then what should be its final velocity? The final velocity V will be equal to, yeah, the final velocity V will be equal to the initial velocity V minus V by 3, isn't it? Yeah. So that's going to be V minus, it has lost one third, right? So that's going to get you final velocity. Let me take it V dash. Okay. So V dash will be equal to V minus V by 3. That will give you V dash, which will be equal to 3 minus V. That's going to get you 2/3 of its velocity. So that's going to be 2 by 3 V, right? So the final velocity over here is going to be 2 by 3 V. V dash will be equal to 2 by 3 V. Got it? Then it's going to penetrate certain distance. After that, that distance will be equal to, that distance will be equal to d into 10 power minus 3 meter. Okay, got it? D into 10 power minus 3 meter. Once it has reached that further distance, what will happen is it will come to rest. Okay, so I just need to get this D. I just need to get this D. Okay, so here I'll be able to generate two different equation. So once I generate two different equation, only one unknown variable will be there. That's going to be D. Once I solve it, I'll get the answer, right? It has to be clear. First, let me do the first kinematic equation that is needed, which will be v square minus u square. That should be equal to 2as, isn't it? So here the v square was 2 by 3 v. This was the final velocity, isn't it? 2 by 3 v square minus the initial velocity, that was like v square, which will be equal to 2a, and the distance it has traveled was 4 into 10 power minus 2 meter. Okay. See, I'll just use the convention of meter because that's going to be handy. Even for the final answer, I'll have to convert it to d into 10 power minus 3 meter. Therefore, meter will be the handy units that I could use over here. See, here I just know the bullet is slowing down. Therefore, it has to be retardation. So if I do the subtraction of this one, obviously that will be negative. Okay, let me do the solving over here. If I do the solving, you would have got, if I do square this one, you would have got like 4 by 9 v square minus v square, which will be equal to 2a 4 into 10 power minus 2, right? Then do the cross multiplication, you would have got 4 minus 9, that's going to get 4. Yeah, minus 9, that's going to give you minus 5 v square divided by 9, which will be equal to 2a 4 into 10 power minus 2, right? Now I have generated the first equation. Next, let me do the second equation. Okay, so the second equation will be between this interval. After covering 4 centimeter, it would have traveled some extra distance before coming to rest. So that extra distance is going to be d into 10 power minus 3 meter. First, I'll just use it as d itself. While doing, you'll get it. So here I'll have to get the second interval, that's between, in that interval you would have got the velocity, initial velocity to be 2v by 3, yeah, 2v by 3, and the final velocity will be 0, right? So that's the parameter interval that we are going to use. So for the second, I'm just going to use the same equation, that's going to be v square minus u square. So for the final velocity, that will be 0, okay, minus initial velocity for the second part, which is going to be 2 by 3 v square, isn't it? So you would have got 2 by 3 v the whole square. Yeah, v square minus u square, that's going to get you 2as. So the distance is like d. You would have plugged in d into 10 power minus 3. Yeah, that was possible. Let me do it this way itself. Fine. So here I've just got the equation. Now we can do the solving, isn't it? Yeah, let me put one more step into it. That's going to get you 4 divided by 9, isn't it? Yeah, 4 divided by 9 v square, which will give you 2ad, isn't it? Now I'm just ready to cancel out these two, uh, take ratios for these two equation. Okay, if I do take those ratios, I'll just take it in this fashion. Equation 2 divided by equation 1, isn't it? Yeah, if I do take it in this fashion, you would have got 2ad, that will be in the numerator, divided by 2a 4 into 10 power minus 2, which will give you 4 by 9 v square. Say I've missed one negative sign over here, so I've got negative, this negative sign, okay. So I've got this minus 4 by 9 v square divided by negative 5 by 9 v square, right? Yes, let me do the solving. If I cancel out, you would have a would have cancelled out, then v square would got cancelled out. Negative and negative, that's going to become positive. These two 9 will get cancelled out. So you would have been left with d divided by 4 into 10 power minus 2, isn't it? Which will be equal to 4 by 5. Yes, 4 by 5, right? If I do multiply this one, you would have got 4 into 10 power minus 2. Yes, right. So if I do the cancelling stuff, that's going to be 0.8, isn't it? So 0.88, that will give you 32, isn't it? So that's going to be 3.2. So d, which will be equal to 3.2 into 10 power minus 2, right? Now I have got the distance in terms of meters, which will be equal to d that is equal to 3.2 into 10 power minus 2, right? The fashion they're asking us to find the d is in terms of d into 10 power minus 3, right? So if you have to get it in that fashion, so that's going to get you 32 into, yeah, I'll have to move one more decimal place over there, so that I'm just not going to disturb this final answer. So that will give you 32. Yeah, if I move one decimal place, so I can multiply by 10 power minus 1, isn't it? Logic should be clear. So that you should have got like 32 into 10 power minus 3 meter, right? So if this is going to be the case, then 32 should be my answer, right? So d should be equal to 32. See, or else you could have solved it in this fashion itself. Instead of d, I could have substituted d into 10 power minus 3. Okay, if I have substituted there, then here in this case, you would have got like d into 10 power minus 3, right? So same way here also, in the final result, you would have got d into 10 power minus 3. If I have divided 10 power minus 3 over here, then you would have got this d value straight away. That's going to get you 3.2 multiplied by 10. That will also give you this 32. But here in this case, I've got the final d. Then I'm just going to make this one 10 power minus 3. If I have to make this one 10 power minus 3, then how should I move the decimal place over here? Here, I'll have to move one place towards the right. If I do one decimal point towards the right, I'll end up getting 32 into 10 power minus 3. Whatever pattern you solve, you'll end up getting the answer to be like 32, right? Got it? The idea has to be clear. No doubt should be there. So here, the answer is like 32. Let me mark the 32. So here, if I just look at the option, you do not have 32. So here, none of the option is equal to 32. Therefore, all the options that they have given in the question is wrong. Okay, so if you get such a kind of question, you shouldn't mark any option. If you leave that question unattended, they'll give you the mark. But if you end up marking the answer, they'll give you the negative mark accordingly, right? So same pattern, same case with the NEET examination. There also I've told you the same thing, right? So if the question is wrong, you shouldn't mark the answer. If you end up marking the answer, they'll give you negative. They'll reward you with negative mark. Or else if you just leave the answer, if you just leave the question unattended, they'll give you the full mark. Okay, got it? You have to be clear with this question. No doubt should be there. Let's move to the next one. Next question is, a juggler throws balls vertically upwards with same initial velocity in air. So there is a circus guy, he's throwing ball vertically upwards, which means he is juggling the ball with same initial velocity, right? So he is throwing upwards. When the first ball reaches its highest position, he throws the next ball. So when the first ball is at its topmost position, he is ready to throw the next ball. Okay, so that's the hint or the condition that they have given over here. When the first ball reaches its highest position, he throws the next ball. Then they have given us, assuming the juggler throws n balls per second. So they have given you the frequency at what rate he is throwing the ball. Assuming the juggler throws n balls per second, the maximum height the ball can reach is. So what I need to get is the maximum height that the ball can reach. So one of the hint that they have given here is, when it has reached its maximum position, the guy is ready to throw the next ball. Okay, so here First, let me explain what is meant by n balls per second. So we'll get used to this notion from the next chapter. So this is what is meant by frequency. At what rate that that same thing is happening again. So here that same thing is actually he's throwing the ball upwards. Okay. So some repetitive stuff is going to happen again and again. So here that repetitive stuff is throwing the ball upwards. Fine. So here let me take a condition, something like this. He is going to throw two balls per second. So this circus guy is going to throw two balls per second. Okay, I'm just going to take it in this fashion. If that was the case, when time t will be equal to 0, he'll be ready to throw the first ball and he will throw the first ball. Okay, so okay, this would have traveled some distance. So here it should be obvious. In 1 second, he's going to throw two balls. Then what will be the time interval for the two balls? That's going to be half a second, right? So in 1 second he has to throw two balls, then he should have taken half of that time to throw the first ball. Okay, he should have taken half of that time to throw the next ball, right? So that's how it has to be. So after t equals half a second, this would have reached certain distance. In the situation, that's going to be the maximum height. Anyway, so when t equals half a second, this would have reached its maximum height. Now he is ready to throw the next ball, right? So when t equals 1 second, he would have been ready to throw the third ball. But in that 1 second interval, he has thrown actually two balls. Okay, the third ball will be for the next interval. That will be between 1 to 2 seconds. So in the t equals 1 second, he is ready to throw the third ball. So that will come in the interval of 1 to 2 seconds, right? So in the first 1 second interval, he threw actually two balls, right? Same way in the interval 1 to 2 seconds, he threw two balls. Same way for the interval 2 to 3 seconds, he threw two balls. So in every 1 second interval, he was able to throw two balls, right? So that is what is meant by two balls per second. Got it? So what will be the time interval between the throw? It's gonna be like half a second. So for every half a second, he is gonna throw one ball upwards, right? So that's the intuition that you need to know. So in the situation, the cycle was throwing the ball. In the next chapter, we will do the circular motion. In circular motion, yeah, the time taken to complete one cycle will be equal to the time period or the time interval. So the inverse of that one will give you the number of cycles that has happened in 1 second. Okay, so we will do that one exhaustively in the next chapter. As if now what you need to know is, here they have given you the frequency. So the frequency is like n balls per second, which means in 1 second he is able to throw n balls. So what will be the time interval of throw between those two balls, which will be equal to 1 by n seconds. Okay, if it was like two balls per second, that's going to get you 1 by 2 seconds. So 1 by 2 seconds will be the time interval between the throw. Okay, in between the throw, right? So here, if I have to get the time interval for the throw, you would have got t, which will be equal to half second. Okay. So now I have got the time interval. Next, what I need to get is when he is about to throw the next ball, the first ball would have reached its highest position. Okay. So now they have given you another way to get this time. So when the first ball has reached its maximum height, initially I would have given some velocity u. Final velocity is going to be 0. That's going to get you gt, right? So I'll be able to use this first kinematic equation. That's going to get you v minus u. That is equal to at. So the final velocity when it has reached its topmost position is going to be 0 minus the initial velocity. That should give you negative g times t. See, this time is the time taken by this ball to reach the maximum height. When this ball has reached the maximum height, I know he was ready to throw the next ball, right? So here, when he was ready to throw the next ball, that should be equal to, if it was like two balls per second, that's going to get you half a second. Here in this question they have given us, they have thrown like n balls per second. So the time should be equal to 1 by n second, isn't it? So here, for this question, for easy understanding, I've just told you like two balls per second, but in the question they have clearly given us that's going to be like n balls per second. So when this has reached its maximum height, the time is going to be like 1 by n second, right? Because he was ready to throw the next ball. So here also, by using the first kinematic equation, I just got the maximum height, because at the maximum height final velocity was equal to 0, right? Therefore this time t and this 1 by n second has to be same, right? You can get this logic by equating the first, by considering the first statement. When the first ball reaches its highest position, I just found this equation. So by considering this, assuming the juggler throws n balls per second, I just found the time interval between those two balls, right? So in the situation, when I was ready to throw the next ball, the first ball will be at its maximum height, right? The before ball will be at its maximum height. So that time interval should be equal to 1 by n seconds. By the way, using the first kinematic equation, I was able to get the time also. Therefore, this time and this time has to be same. The logic should be clear. Yeah, we shouldn't have any confusion over there. Therefore, here with this consideration, if I do solve this one, t will be equal to u divided by g. I know this one and this 1 and 2 are just this same time. Therefore, I'll be able to equate those two stuff. If I do equate those two one, I'll end up getting 1 by n, which will be equal to u by g, isn't it? Therefore, u will be equal to g divided by n. Got it. So now I have got the initial velocity with which this juggler is going to throw the ball upwards. Okay. So the velocity with which he needs to throw will be equal to g divided by n. If it was 2 balls per second, then it has to be g by 2. If it was like 3 balls per second, then it has to be g by 3. Accordingly, he's going to juggle the ball. Okay. Anyway, what I need to find here is actually the maximum height. If I have to get this maximum height, I just know the initial velocity. I know at the maximum height, the velocity is going to be 0. The unknown parameter over there is the height. So I'll be able to use the third kinematic equation. That's going to be v square minus u square, which will be equal to 2as, isn't it? So if I do use that equation, you would have got v square minus u square, which will be equal to 2as, right? Final velocity will be 0 minus the initial velocity. That's going to be this one, g by n, the whole square, which will give you negative 2g. Acceleration is downwards. And I should have got the maximum height, isn't it? So this is what they're asking us to find, isn't it? Yeah. So h will be equal to g square divided by n square multiplied by divided by 2g, isn't it? So if you cancel this one, I'd have got g will get cancelled out. Then you'll be left with g divided by 2n square. So this should be my answer, g divided by 2n square. Yeah, the answer over here is option 4. See, you should be clear with this question. You shouldn't have any doubt in this question, right? So what I've done over here is, there was a circus guy who was throwing the ball upwards, and there were like two conditions. The first condition is when the first ball has reached its highest position, he was ready to throw the next ball. Okay, so that hint should be there. Then they have given us he is throwing ball with an interval of n balls with a frequency of n ball per second. So what will be the time interval between the throw? So the time interval between the throw will be equal to 1 by n seconds. So flip it, you'll get the time interval for the next throw. Okay, so that will be the time interval. So here I know when the first ball has reached the maximum height, he's going to throw the next ball. So I just know the time interval. It would have taken 1 by n seconds. So that is done. So when he is about to throw the next ball, the first one has reached its maximum height. Therefore, now I'll be able to get the time based on the first kinematic equation, right? Because final velocity is 0, the initial velocity is u. So t will be equal to u divided by g. That stuff is done. Then, when I know these two time, I'm just going to equate this u by g, which will be equal to 1 by n. So from that, I'll get the initial velocity u. So now I know the u. What they're asking us to find is the maximum height. So to get the maximum height, use the third kinematic equation. Just plug in all those unknowns. You'll end up getting the maximum height, right? It has to be clear. Yeah, no doubt should be there. Let's move to the next question. Next question is, water droplets are coming from an open tap at a particular rate. Okay, so you're having a tap which is open, partially open, and the water is dripping from the tap, okay, at a constant rate. Got it? The spacing between a droplet observed at 4 seconds after its fall to the next droplet is 34.3 meters. So what they've given is when the first droplet has dropped, and after it has traveled a time of 4 seconds, the spacing between that first droplet to that of the next droplet which has dropped afterwards it will have a distance of 34.3 meters. Okay, so the spacing between the first and then the second drop is going to be 34.3 meter after the first droplet has traveled a time of has crossed a time of 4 seconds. Okay, after at what rate the droplets are coming from the tap. So what I need to get over here is at what rate the droplets are actually falling from the tap. That's what I need to get over here, right? First let me draw the diagram. So you have got a tap, and from the tap the water is dripping. Okay, so the first drop that has yeah dripped from the water has traveled has taken a time of 4 seconds. So the time for this one will be like 4 seconds. Okay, so if I know that one, yeah, I just need to get the height of this one, right? So let me take this height to be h1. Okay, so then what has happened is the next water droplet started spilling, and the next water droplet has should have traveled certain distance. Okay, I do not know the time that it has taken, but only thing that I know is that the distance, the height distance between these two, the distance between these two water drop. So the distance between these two water drop was equal to 34.3 meter. So this is now. So what I need to figure out over here is this distance, the distance that this water droplet has traveled is actually h2. Okay, so here I just know the one height which is like h1, that has taken like 4 seconds to reach this position, but I do not know this h2. Instead I know the distance between, yeah, h1, the distance between these two water droplet, which is nothing but the h1 minus h2, right? So I just know h1 minus h2. So that should give me 34.3 meters. So if I know this one, I'll be able to calculate the time that this second water droplet has taken. So if I know the time that this second water droplet has taken, obviously the time interval between those two, whatever two water droplet will be, I could find out that one, right? Because here if I know the time taken by the second water droplet, obviously that will be less than that of this 4 second. If it was less than that of that 4 second, I just know the time interval between two water droplets. So once I know the time for that interval or time of drip, if I know that one, then obviously which that should give me the time interval. If I just flip it, I'll end up getting the rate at which water drops are falling down, right? So in the previous sum, with the case of jugular sum, they have given us the rate and they asked us to find the maximum height. In this question, they have given us the time and then they're asking us to find the rate. Okay, so it's kind of other way around, right? So just two more steps, I'll get the answer. First, let me get the height h1. So what will be the height h1? I know the initial velocity was 0, therefore ut, that term will go to 0. Only stuff that is left is half at square, right? So here I could substitute like negative 10. Here I just clearly know the water droplets are falling downwards. Only stuff that I'm worried about is the difference between h1 and the h2, right? So do not want to worry about the negative sign. You should get the notion that I'm telling you. Anyway, half 10 t square. So what should be the t square? That's going to give you the 4 square, right? So this will give me, yeah, the this should actually give me 16, right? So here it will be like 16. So if these two stuff cancelled out, that's gonna give you 8. So the h1 over here is like 80 meters. Fine. So now I have found out the h1, which is like 80 meters. Got it? So if I do subtract 34.3 meters from this 80 meters, I just know how far this second water droplet has traveled. Once I know this h2 distance, obviously I will be able to get the time that this water droplet has taken to reach this height h2. So if I know the time taken for this second water droplet, subtraction between the first and then the second water droplet will give me the time interval, right? So once I get this time interval, I just know the time interval for the two water droplets. Just flip it, you'll get the rate at which the water droplets are coming from the tap. Okay, here you have got this 80 meters. Fine, it has to be clear. Then to get the h2, yes, h2 will be equal to h1 minus h, isn't it? H was equal to 80 minus 34.3 meters. Fine. Let me approximate it. If I do approximate this one to 35, you would have got. So if it was like 35, then it's gonna be 45, isn't it? 45 meter. Yes. So 50, yeah, 45 meters. So h2 will be equal to 45 meter. So now I have got the h2. So if I know the h2, I just need to get one more thing, which is going to be the time t, isn't it? So same equation, s equals ut plus half ad square. So that will give you 45 half a. For the a, I'll substitute like 10, and then I just need to get the time t square over here, right? So t square is the unknown, that is something that I need to get. So if I have to get that one, so just do the rearrangement, you'll get that one, right? So 45 multiplied by 2 will give you 90, which is equal to 10 t square. So these thing will get cancelled out. Therefore, t will be equal to 3 seconds, right? T square is 9, therefore t is equal to 3 seconds. So now I have got the time for the second water droplet, which has dripped after the first one. So that's going to be 3 seconds. So here, this time is the 3 seconds, okay? So here I just know the time taken by the first time, total time taken by the first water droplet and the time taken by the second water droplet, okay, at the same instant. So for this one it's going to be 3 seconds, and for this one it's going to be 4 seconds. So at what, so what is the time interval between those two water droplets? That's going to be like 4 minus 3, therefore t dash will be equal to 4 minus 3, so that will give you 1 second. So the time interval over here is 1 second. So for every 1 second, water is going to drip from that water droplet. So if the first water drip at time t equals 0, then after 1 second, the second water droplet will drip. Okay. So here, the time interval between two water droplet is actually 1 second. So if I just flip it, I'll get the rate, right? So one, flip the one, you'll end up getting the one. So that's going to be the rate over here. So the answer over here is actually 1 drop per second. So every 1 second, 1 drop of the water is going to drip, right? Therefore, the answer here is option 2, right? You should be clear with this sum. You shouldn't have any doubt on this question, right? So to solve this question, what I did is I just used this second kinematic equation, ut plus half at square. So here in the question, they have clearly told us the spacing between those two water droplet was equal to some 35 meters. Okay. And the first droplet has taken like 4 seconds. If I know that one, I'll end up getting the height, the distance traveled by the first water droplet. So to get the distance traveled by the second water droplet, just subtract the 35 or 34.3. We'll get the distance traveled by the second water droplet. Now I'll be able to get the time taken by the second water droplet. So once I know the time taken by the second and then the first water droplet at that particular instant, if I do the subtraction, I'll get the interval of dripping for the water. So once I know the interval of dripping, if I just flip it, I'll end up getting the frequency or the rate at which it is dripping. Okay, water droplets are dripping, right? So the rate is going to be 1 drops per second. Got it? It should be clear. Let's move to the next question. Next question is, an engine of a train moving with uniform acceleration passes the signal post with velocity u. So there is a train that is moving with a constant acceleration, and then it passes a signal post with the initial velocity u, and the last compartment with velocity v. So the first part of the train, which is going to be the engine, that's going to travel that post with the speed of u, and the last compartment is going to travel with the speed of v. As it is undergoing an uniform acceleration, obviously, when the last one is going to pass, the velocity is going to be more. The velocity with which the middle point of the train passes the signal post. Okay. So what will be the velocity when the middle section of the train is going to pass? Okay. That particular signal post. So you are having a signal post. Okay. And then you got a train. When the front end of the train is going to pass the signal post, the velocity was u. Okay. And when the last compartment was about to pass the signal post, the velocity was v. So what they're asking us to find is, if what will be the velocity with which this middle what will be the velocity of this train when this middle the middle section of the train is going to pass, okay? That particular signal post. Fine, so I just need to get this V dash. They have given you the condition. The initial velocity is like U. The initial velocity with which it was able to pass the signal post was like U. And when the train was about to leave that signal post, it had a velocity of V. Then what will be the velocity when the middle section of that train is going to pass that particular post? That's what I need to get, okay? So here, if you look at this question, there wasn't any data that was given related to the time, right? So only thing that I know is the length of the train. Got it? So L is something that I could actually use to solve this question because the length of the train is going to be fixed, right? So initially it was 0. Okay, when it has traveled a distance L, the final velocity will be equal to V, and V dash is something when it has traveled a distance of L by 2, isn't it? Okay, so after covering a distance of L, it has a velocity V. Initially, when it hasn't crossed the signal post, I can consider that to be 0 position. So at that time, the velocity was U. When it has traveled a distance of L, the velocity was V. Same way, when it is in the mid section, when it has crossed half of the train, that length can be matched with L by 2, right? So at that point, the velocity was like V dash, right? Now by using all these datas, I'll be able to solve the question. So here, the kinematic equation that I'm going to choose is like the third kinematic equation, which will be v square minus u square, which will be equal to 2as, isn't it? So for the first condition, that's going to be same as such. Instead of this s, I'll substitute l. So I would have got v square minus u square, which will be equal to 2al. Okay. Then for the next one, the initial velocity will be the same u, but the final velocity is something that I need to get right. Therefore, you would have got v dash square minus u square, that will be equal to 2a l by 2, right? Next, if I just take the ratios of these two equations, I'll end up getting the answer. Just let me do the ratios, I'll get the answer straight away. So here, if I do factor this one, yeah, I would have got like 2. Yes, so the next step will be v dash minus u square divided by v square minus u square. That should have given us 1 divided by 2, isn't it? Yes. Just do the cross multiplication. If you do the cross multiplication, you would have got, yes, missed one square over here. So you would have got 2v dash square minus 2 u square. That should have given us v square minus u square, right? Okay. So you should have got 2v dash square, which will be equal to v square plus u square. Okay. This will go to the denominator. Yeah, this one will go to the denominator, and the next one is like root of, yeah, just remove this root. You would have removed the square, you would have got root of v square plus u square divided by 2. So that's going to be option 4. V square plus u square divided by 2. That's like option 4, right? You should get this question. So this question is a simple one. So initially, they've given you the initial condition, which was before crossing the signal post. Okay. After crossing the signal post, the velocity was v. Then what they're asking us to find is the new v dash, which was the middle section of the train when it was about to pass that signal post, right? So use this kinematic equation, third kinematic equation, because length is something that I'll be able to operate on, but they haven't given anything related to the time. That's why I just left that first and then the second kinematic equation. So I generated like two different kinematic equation. I just took the ratios, equated it. I ended up getting the answer, right? It has to be clear. Let's move to the next question. This question is graphical based question, a little bit tricky. Let me read the question. A tennis ball is released from a height h, and after freely falling on a wooden floor, it rebounds and reaches a height h by 2. Okay, so you have got a ball, and I'm going to drop it from a height h. It hits the ground, and then it rebounds back to the height of h by 2. Okay, so the energy is not conserved. Some of the energy has been dissipated to the surrounding. and in that situation it rebounds to the height of half of the initial height. Okay, so that's going to be h by 2, right? Then they have given us the velocity versus height of a ball during its motion may be represented graphically by, so I just need to get the graph between velocity and then the height and then the velocity, right? So I just need to get this relation between these two parameters. Okay, a graph are drawn schematically and not to not to scale. Okay, so this is just an representation of its position. First I just need to get the equation that's going to relate between position and then the velocity. Okay, so the equation that I could choose for a uniformly accelerated motion will be the third kinematic equation, that's going to be v square minus u square, which will be equal to 2as. So that's the equation that I'm going to choose. Okay, so here first I'll just tell you the scenario, what's happening over here. You have got a ball that I'm going to drop it. Okay, so there is a ball and it is at a height of h. Okay, this is the initial position and then I'm going to drop it. Okay, so it just drops and then it comes to the, it hits the ground and then it rebounds back to the height of h by 2. Fine, so I have to find the relation between, yeah, I have to find the relation between the height and then the velocity at every instant. So when it is at a height of let's make it this way, h by 3, from the point where it has dropped, what will be its velocity? So I have to get the relation between, well, its position with respect to the motion and its velocity in that particular position. That's what I need to get over here, right? So when you look at this graph, it should be obvious the relation is between the height and then the velocity, right? So to get this relation, first let me think through it, how will it actually depend. So just by logically thinking the motion, I'll be able to neglect two of the graphs. Okay, so rest two will be a little bit confusing, for which I need the equation to get to that understanding. Got it? So first, initially it was at certain height h and then I dropped it, right? So how should the velocity actually be? As I move downwards, the velocity has to increase, right? As we move downwards, the velocity has to increase. So what is the direction of motion in this case? So here the h is actually decreasing and the velocity is increasing as we move down, right? So if you look at the first part, if you look at this first part of the equation, the h is initially it was some greater distance that was equal to h. Okay, obviously the above part of the graph should be the second motion because that's going to be h by 2, right? So it is at its initial position, which was equal to h, and then it started slowly moving downward. So the height was in the negative, I mean the height was decreasing, isn't it? It was 10 meter from the ground, then it started decreasing, therefore the height started decreasing. What will be the direction of velocity? It was in the negative direction, therefore that's going to be downwards. Okay, so first graph is possible. Then if we look at this second graph, that doesn't make sense at all, because the velocity was increasing in the negative direction, then suddenly it started then suddenly it started decreasing in the negative direction and then it went to zero. So this is not possible, right? Okay, so obviously option 2 is not possible. That's straight away neglected. Then if you look at this one, here they have given you in the straight line is not possible, because anyway the relation will, when you look at that equation, v square minus u square equals to as, it is related in terms of squares. Obviously there should be some quadratic stuff into it, it has to look like a parabola. And we know that it is not possible that to be a straight line, because that equation in itself is not a straight line equation. Okay, so obviously option 2 is also not possible. Then if you look at this fourth equation, it should be obvious. Yes, here also the same explanation that I've given over there. It was at an height h, and as we moved on, the velocity was increasing in the negative direction, and when it hits the ground, the velocity was at its maximum. So either it could be something like this, yeah, something parabola open downwards, or it could be like the parabola open upwards. So these two stuff are possible. Fine. So to get to this result, I'll have to first figure out the equation, which will be the kinematic equation, third kinematic equation. I'll use that equation. Then I'll have to plug and play accordingly, and I'll have to separate between, I'll have to segregate between that h and then the velocity, right? Okay. So let me do it. Yes. Okay. So let me do it and you'll get it. So here I'm going to consider this equation, which is like v square minus u square, which will be equal to 2. What will be the acceleration? That's going to be minus g. Fine. So in this situation, the way I'm going to get the height is, yeah, if I have to get the displacement, how will I get the displacement? Final position minus the initial position, right? So at every position, I just need to know its velocity. Therefore, instead of substituting like h straight away, that displacement straight away, I'll just plug in the positions over here. Okay, so the positions will be, yeah, it's going to be like final position minus the initial position. That will give me the displacement, right? The way I have put here initial velocity and then the final velocity, same way, instead of plugging it straight away displacement, I'm just going to put the position, which is like h2 minus h1. So h2 will be the final height minus the initial height from where it has been dropped. Okay, so here I'll substitute h2 minus h1. Yeah, the idea and notion has to be clear. Yeah, the argument should be clear. Fine. Okay, let me rearrange this one and I'll just get it for the first part of the motions. So what will be the first part of the motion? It's gonna drop downwards. So when it is about to drop downwards, what was its initial velocity? Initially it was at rest and it was freely falling, right? Therefore the initial velocity has to be 0 because it was released from height h. Okay, therefore in this situation the initial velocity u goes to 0. That's done. Okay, so just rearrange it, you'll get the answer. You'll get the understanding behind it. So if I do the rearrangement, you would have had, yeah, that's gonna be v square, yes, which will be equal to minus 2g h2 minus 2g, no, let me write it this way itself. You would have got this negative 2g will come to the denominator, therefore you would have got like minus 2g h2 minus h1. Okay, so what is the h2 over here? So h1 will be the height. Okay, so this h1 is going to be some positive term from the ground surface, therefore that's going to have some 10 meters or something like that into it. H2 is something that will vary depending on the final position, right? Therefore, I have to get the relation between H2 and then the V, right? So H2 and then the V does make sense because initially it was at certain height H. That's not going to change. If I'm going to drop it from the height 10 meters, this H1 will always be 10 meters. So that was the initial position. So based on the velocity, this H2 will change. If the velocity was less, it has covered less distance. If the velocity was more, then it has covered more distance. So only stuff that's going to change over here is these two parameters, which is like velocity depending on the position h2. Okay, so if h1 is constant, because that was the point where I dropped it. Okay, so if I rearrange this one accordingly, you would have got, yeah, you would have got h2 which will be equal to negative h2, that will be equal to minus v square divided by 2g, yeah, minus v square divided by 2g plus h1. Okay, so if you look into this equation, you have to get this idea. So initially when I was about to drop this one, initial velocity and the final velocity was just the same. If you just plug 0 over there, h2 will be equal to h1. So that was the starting position. Yeah, obviously. Then once this started moving downwards, the velocity will increase. As this term is going to increase, so this will start rising slowly. If this was like 10 meters, this will have like 2 into it or 1.5 into it. Accordingly, this will be negative, this will be positive, right? Okay, so accordingly, what will happen? This h2, yeah, this H2 will start decreasing. Initially, H2 will be at its maximum position. Initial and final position will be same. Then this H2, which will be the new position, that will keep on changing, or it will just keep on decreasing because this negative value will increase. Accordingly, these two stuff will nullify, and there will come a point where it will hit the ground. It wouldn't be able to move beyond the ground surface. That's not possible. Therefore, there will come a point where H2 will be equal to 0, which means this entire term will match with this term, therefore these two stuff will get cancelled out, right? So that's how the equation is going to be. So anyway, I have formulated the equation over here. So if you look at this equation, how does it look? This looks something like this, right? A parabola which is like h h2 is nothing but the position h over here. So I can just write this one as h with respect to v, with respect to the velocity. Therefore if I consider this equation, y equals negative x square, right, plus some constant c, that's going to be h1 over there. So if you get such an equation, what does it actually represents? This is a parabola open downwards, right? So this is going to be the parabola open downwards. Fine, so let me draw the diagram accordingly. If I drew the diagram, you would have got, yeah, let me draw it over here. So for y, I'll have to put the h of v. So h of v will be in the y-axis, and then for the x, I'll put like v. Okay, so that's how it has to be. But if you look at these graphs, it's going to be other way around. So v was over there and h was over there. So once you get this h and v graph, I'll be able to change it. Okay, that's an easy one. Just rotating it, you'll get this other way around. That's an easy one. First, let me just mark it straight away based on this equation. If you get such a graph, how will it look? It will be like parabola open downwards, right? So in the situation also, it's going to be like parabola open downwards. But the point is, you would have got some plus constancy into it. Therefore, it will not start from the origin. So it will start somewhere above from the origin, right? That has to be clear, right? Okay. You shouldn't have any doubt. So in such a situation, yeah, in such a situation, so here the h has to be at its maximum position, right? And then how will the direction of velocity be? The direction of velocity will be in the negative direction, right? So h will be in the positive direction. As you move downwards, the velocity will increase in the downward direction. Therefore, it shouldn't be in the first quadrant. It should actually be in the second quadrant. Okay, I should consider this part of the graph. Therefore, this should be a parabola open downwards, and it has to be in the second quadrant, something like this. And then it will reach the h, which is going to be 0, right? So when h equals 0, h1 and this entire term will match with each other. At that point, h2 will be equal to 0, which is nothing but the h with respect to v. So this is how you will have this graph. Okay, so now the first part is done. Now I have to do the second part. You shouldn't have any doubt on this stuff that I've done over here. What we did is we just took that kinematic equation. So instead of s, I just plugged it with its position, final position minus initial position, because at every single instant I just need to know its velocity. So I'm just comparing it in that fashion. Therefore, I've just substituted h2 minus h1, right? So same way I'm going to put it for the ball that's going to bounce back to the height h by 2. Okay, so same thing, but we'll take like different zeros into it depending on the situation. So here for the next part, you would have got, for the next part you would have got same way, v square minus u square. Yeah, initial velocity, you had initial velocity into it, right? Yes, you had some initial velocity into it that was equal to, yeah, some initial velocity. So that's going to be v square. So on different position the velocity is going to decrease, but still you will have final velocities into it. So v square minus, in the first situation I just dropped it, therefore initial velocity was 0. When it bounced back from the ground surface, in that situation it had initial velocity into it. Okay, so minus u square, that's going to get you 2g to negative g. Same way, h2 minus h1, isn't it? Same equation, but here in the situation I wouldn't be able to plug in, yeah, I wouldn't be able to plug in 0 for that initial velocity. Okay, so this one has to be clear. Here with the case of h1, I mean h2 minus h1, right? So h1 is going to be the initial position. With the case of h1, I can just put it 0. Okay, because initially when it just bounced from the height, h1 didn't have some value into it. Initially it was 0, right? Therefore here in this situation I can put h1 to 0. So this term can go to 0. Now just rearrange it accordingly, and see, I'm going to make the same kind of argument that I made for the ball falling downwards, and then I'll get the next part of the graph. Okay, so if I have to get the one, it will be something like this. First I'll have to segregate the constant term from it, right? So if I have to do that one, you'd have got v square minus u square divided by negative of 2g, that will give you h2, right? Now I'm just ready to get the h2. So h2 will be the final position, right? So if you have to get that one, you would have got h2, which is nothing but the h of v, right? which is nothing but the h of v. H2 will be equal to, just do the inner multiplication over there, you would have got negative v square divided by 2g. So minus, no, that's going to be plus u square divided by 2g. Okay, so this is the equation that I've got over here. So if you look at this equation, first I'll have to split the constant term. So the constant term over here would be this one, u square divided by 2g, because initial velocity, you had some initial velocity to it. So you're going to have that initial velocity over here. So this entire term is nothing but the constant. So this entire term will be the constant. The way h1 was there in that situation, here h1 is 0. Fine. So if you look at this equation, h2 which is equal to negative v square divided by 2g, right? Even in this situation, it's going to be the parabola open downwards. Yeah, it's going to be the open downwards. See, if you have to imagine this one, initially you would have, initially the, if you have to get the initial position, that's obviously 0, right? So h1 has to be equal to h2. So initially the initial velocity and final velocity is going to be the same. Therefore these two terms, minus u square divided by 2g plus u square, these two stuff will cancel out, and then it will produce 0 over there. As the ball starts moving upwards, this term is constant. What will happen to the final velocity? It's going to decrease, right? Because as it moves upwards, the velocity is going to decrease. Therefore as you move upwards, what's going to happen over there is the velocity will just drop. Okay, so when this part of the velocity is going to drop, you know, let me take it this way, this is like 10 initially and this is z. Initially these two stuff is going to be same. So initially this is like 10. As it starts moving upwards, you will generate some values to it, right? Let me put it this way, this is like 10, there was small decrease in the velocity, therefore this was like 9, so the difference is going to be like 1. So it has moved 1 meters upward, then again it would have moved some to 1 meters upward, and the velocity will start dropping. Okay, so here even in this situation, this is going to be the parabola open downwards. Okay, but as you move upwards, the velocity was actually dropping and the velocity was in the positive direction, right? So let me draw the graph for this particular condition. If I have to draw the graph for this particular equation, it will be something like this. Initially they have told you it has reached the maximum height of h by 2, but I know initially the height was 0, right? But you had velocity into it, right? So initially you had certain velocity into it, but the height h was 0, then it started moving upwards. Therefore the velocity was decreasing, but still it was in the upward direction and it started moving upwards, right? So we should get a graph something like this. Yeah, it should move upwards. Fine. This, even if you look at this graph, this is also a parabola that's going to be open downwards. See, the reason why I have just put this a little bit low when compared to the to that of this one is because, to the first part is because it is going to reach a maximum height of h by 2. It's not going to reach the maximum height of h, instead it's going to reach a height of h by 2. Okay, so here for the second part, it's going to reach a height of h by 2, but with the first case, it was dropped from a height h. Okay, that's why I just put it little bit down when compared to this total height, right? Now I have got the graph, so only part that is left is I'll have to match it with either option 1 or option 4. When you look at the option 4, it should be obvious that's not possible because this seems to be parabola open upwards. That's not the case over here. It should be the parabola open downwards, isn't it? Therefore I'll have to match this one. So I'll just have to swap these places. So here V is over here and H is over there. So H has to come here to the x-axis and V has to go to the y-axis. So if you need to switch its places, how will it look? So this part will come here, right? So you have to flip it like 180 degree. You just have to do the imagination. Okay. So here what has happened? It started from the maximum height and then it was, the velocity was increasing, and then it came a point where the velocity was maximum and it hits the ground. So that should match with this part, doesn't it? If I just flip it by 180 degree, just mirror it, once you flip it, you would have got this one in this part, right? So obviously even if you look at this graph, h was like positive, same way h was like positive, v was in the negative, v was in the negative, right? So it did match. And when you look at this graph, it is obvious initially the initially the slope was greater, and as you move towards the 0 with respect to the height, the slope started falling down. Same way initially the slope was maximum, and then as you move towards the velocity, as you move towards the 0 height to the ground, the velocity was actually, the increment in the velocity was falling, but it was increasing at a slow pace. Okay, got it? So it should be obvious. This one will match with this one. The other way around is not possible, because in this case it was like parabola open upwards, which means initially the velocity was increasing slowly, finally it was increasing rapidly. The slope was other way around. That's not possible. Okay, so if you just switch places, if you just do a little bit of imagination, you will get it right. So initially the h was at its maximum position, right? Then the slope was maximum, so that's how it is also over there. Then when it reached the velocity, when it reached the height to 0, the velocity reached its peak, but the slope became shallow. Okay, and finally it was equal to 0. Fine. So the logic has to be clear. Same way, if you look at this one is done. Same way here, if you look at this part of the graph, the velocity was maximum, right? The height was 0. Okay, then the velocity started decreasing, but it was still in the positive direction. Okay, and there came a position where the velocity became 0 and the height became h by 2. Therefore option 4 should be my answer, right? Yeah, it has to be clear. See, little bit tricky some, because we haven't seen much related to the graph based sum, isn't it? Yeah, this is little bit tricky. You should get this question. So once you are thorough with the interpretation of graph with respect to the equation, you will be able to get this question, right? You shouldn't have any doubt in this question. It has to be clear. Let's move to the next one. This question is also graph based one. The question is, two stones are thrown up simultaneously from the edge of a cliff to 40-meter high with initial speed of 10 meter per second and 40 meter per second respectively. So there is a guy who is standing on the edge of the cliff, and then it is at a height of 240 meters from the ground surface. Okay, this guy is throwing two stones, one with a speed of 10 and the other one with a speed of 40 meter per second simultaneously at that same instant itself. Then which of the following graph best represents the time variation of relative position of the second stone with respect to the first? So here the second stone was thrown with like 40 meter per second, and the first stone was thrown with a speed of 10 meter per second. I obviously know this 40 meter per second stone is going to reach late to the earth's surface, but this 10 meter per second, it was thrown with lesser velocity, therefore it will just climb up to a certain minimum height and then it will fall down. But with the case of 40 meter per second, it is going to climb to much more greater height and then it will fall down, right? It is going to move up to much more greater height, right? Okay, assume stones do not rebound after hitting the ground and neglect air resistance. Take G to be 10 meter per second square. The figure or schematic are not drawn to scale. Okay, so same way, based on the equation, I just need to get the graph. Okay, so if I have to get the graph, first I need to know, first I need to know its position, isn't it? So to get the position, and yeah, I have to get to know its position based on its velocity, based on the time, right? So to get that stuff, yes, initially there was a guy who was standing at this part of the cliff, and then he was throwing this upwards. First one was thrown with a speed of 10 meter per second. Okay, so I have to get the relation between the time and then the height, isn't it? So if I have to get that relation, it's gonna be something like this: s equals ut plus half at square, right? So here, if I have to plug it in, it's gonna be like y2 minus y1. Okay, so instead of s, I'm gonna put its position. So final position minus the initial position. Okay, I'll fix the initial position as if now y2 minus y1, and then you would have got the initial velocity was like upwards. Therefore, you would have got like 10 time t minus half g t square. So this should be the relation between the position and then the time. Okay, so initial time is obviously going to be 0. So for, let me fix the y1. So y1 over here, I'll consider this to be my origin. Okay, so if I consider this one to be my x equals 0 as my origin, then the ground surface will be at x equals minus 240 meters. Okay, so generally where I'm going to throw, I'll put that one as origin, therefore it will be easy for me to do the calculation. Okay, so this one is going to be my origin and the ground surface is beneath that at a negative direction of minus 240 meter. Okay, so that's y, right? So I'll just change the notation over here. So this is going to be y. Okay, so here this is like y equals 0 and this is like y equals minus 240 meters. Okay, so then in this situation, the point where I threw the ball was y equals 0, therefore this term will go to 0. So obviously this is going to be 0, so y2 has to be equal to, yeah, y2 will be equal to 10t minus half, okay, gt square. Okay, now I have got the y2 with respect to the first condition. Then what will be for the second condition? For the second condition, that's going to be 40. That's it. Then let me write it for the second equation. So that's going to give you, I'll just put it as y2 dash minus y1 dash. Same way, the y1 dash is going to be 0 because from the same point, I'm going to throw the second stone. Therefore, y2 dash minus y1 dash is going to be 0, which is equal to 40t minus half gt square, isn't it? If I have to get this difference, okay, what they're asking us to find is which of the following graph best represents the time variation of relative position of the second stone with respect to the first. Okay, so they're asking us to find the relative position of the second minus the first. So what was the position of the second stone subtracted from the position of the first stone in that instant? So in every instant I have to find this difference. So we have seen this concept relative velocity already while discussing the theory. So relative velocity actually means final velocity minus the initial velocity. Velocity of the first object with respect to the velocity of the second object. Same way here they are asking us to find the relative position, which means what will be the difference in what will be the gap between the position of the second stone with respect to the first stone, because we know the second stone will be traveling much more faster when compared to that of the first stone. Therefore it should be obvious that the position of the second stone minus first stone will give you the right answer, right? So here if you look at the question, here if we look at the equation that I have derived, it should be obvious, that y2 dash minus y2. So this is the relative position, this is the position of the second stone, this is the position of the first stone at the same time interval, right? So if we substitute t equals 1, same t you got to substitute over there, so t has to be same. And if you do the difference between y2 dash minus y2, that will give you the relative position between the second stone and then the first stone at that frozen instant, right? So here it has to be y2 dash minus y2, which will give you 40t minus, yeah, let me write it, 40t minus half gt square subtracted from negative 10t plus half gt square. I just multiplied it. So negative half gt square plus half gt square will get cancelled out. Then you will just be left with 30t. So y2 dash minus y2 will give you 30t. y2 dash minus y2 will give you 30t. So here the relative position between the second stone with respect to the first stone will always be equal to 30t. So that's going to be constant, fine. So this is equal to 30t. Yeah, so that's what they have given over here. Along the x-axis, the time was t. Okay, along the y-axis, they just plugged it in. Relative position of the second stone minus the first stone. Here, for the solving part, I just took it as like y2 dash minus y2. But here they have just given it as like y2 minus y1, because I just considered y1 as the initial position of that first stone. Okay, so whatever it is, they have just found the difference between those two stuff. So y2 dash minus y2 here and y2 minus y1 over here should be same. Got it? It has to be clear. So it was equal to 30t. So 30t was right. Okay, so it was increasing linearly. It should be like 30t. Fine, that is fine. So there is an instant after 8 seconds you are getting something different. So up to 12 it's going to be at the constant rate. Is that correct? Or after 8 seconds, something else is going to happen. So what is that 8 second? What is it going to happen after at that 8th second? That's what I need to get. So at this 8th second, what will happen is this first zone, which was traveling with the speed, which I threw with the speed of 10 meter per second, has reached the earth surface, because with respect to this first zone, if you put like, yeah, if you put like 8 into it, you'll get the answer to be negative 240. For example, let me do it. So you would have got like 10 into 8, that's going to get you 80 minus half. For the G, I'll just substitute 10, and then for the T square, it's going to be 8 square. That will give you 64, isn't it? If I do substitute, if I do cancel this one, you would have got like 320, 32. So that's going to get you like 320. Yeah. So 320 minus 80. Yeah, it should give you like 60, 20. Yeah, it should give you negative 240, isn't it? So that's going to give you minus 240, which means at 8th second, the first ball would have reached the Earth's surface. Okay. At the 8th second, the ball that I threw upwards with the speed of 10 meter per second has reached the Earth's surface. So the first ball has reached, but with the case of the second ball, it hasn't obviously reached because I just threw it with some extra velocity to it. So it is still in the motion. Okay. So it is going to reach at 12th second. Fine. So that is why they have given you 12 clearly over there. Got it? Then how should I get for the interval between 8 to 12 second? That's what I have to get. So here, same way, I'm just going to do the same subtraction. If I have to do the same kind of subtraction, how will it come? You would have got y2 dash minus y2, isn't it? The y2 dash is going to be this equation again. So now it is after 8 seconds. So you'll get the same equation, right? 40t minus half gt square. But with the case of the first stone, it has reached the ground surface. Therefore, the position is going to be same. That's going to give you the answer minus 240 meter. It is the same because once you substitute 8 over here, you got the answer to be like minus 240 meter, which means it has reached the ground surface, after which its position is not going to change, right? Therefore, y2 dash is going to be is going to be changing depending on the time, but after 8 second, y1 dash, oh, I mean y2 is not going to change because that's going to be constant, because the first stone which was traveling, which had an initial velocity of 10 meter per second, has reached the ground. Okay, therefore negative of, so you should have got like minus of minus 240, isn't it? Because I have already fixed the coordinates, therefore it has reached the negative 240, it's not going to change. So this will be my subtracted value, isn't it? So you would have got something like this: 40t minus half gt square minus plus 240. Okay, if you just substitute 12, as I've already told you, if you just substitute 12 over to this equation, y2 dash, you would have got 240 minus 240 at the 12th second. So at the 12th second, these two stuff will get cancelled out and both will be at its ground surface. Okay, but between 8 to 12, that's not going to be the case. So in that interval, how will the equation look like? So how is that graph actually? So this is going to be my y-axis. That's what it was in the y-axis. Okay, so if you look at the graph, it was like 40t, fine, minus half gt square. So t, if you look at the t, it is obvious this is an quadratic equation. By the way, it is a parabola and the parabola is open downwards, right? So it has to be open downwards, right? Because negative, and it has to be open downwards, right? Fine. So obviously y2 minus y2 dash minus y2 was in the y-axis, so that's going to be my y, and t was in the x-axis, so that you do not want to do any flipping in this case. So 40t minus half gt square, right? So this is going to be a curve that's going to be open downwards. Got it? So it has to be a curve that has to be open downwards. Therefore, this is like open upwards. This is not possible. This should be the case. Okay, so the answer over here is option 1. Got it? Yeah, this sum is also a little bit tricky and lengthy. You have to get this question. You shouldn't have any doubt on this question. So these are graph based question. Just practice more of graph based question. So all kind of graph based question are going to be something new. Fine. So if you are just thorough with interpretation of equation into a graph, you'll be able to solve this question, right? So here the imagination is such that I'm just going to throw a ball upwards from the cliff, right? So it moves up and then it just comes down. When it was moving upwards, one ball had a velocity of 10 meter per second and the other one had 40 meter per second. So it should be obvious the ball that I threw with a speed of 10 meter per second is going to reach the ground faster. Okay, it's going to reach earlier and compared to the other ball, right? So what they're asking us to find is the relative position difference between those two stones. Okay, so the relative position between those two stone will be equal to some constant value. That was something like 40t in this situation, isn't it? So that was like 30t. But after the first stone has reached the earth's surface, that's not going to be the case. with the second stone because it is still in the motion. Therefore, that has reached a constant value. But with the case of the second stone, that's not the case. It is still moving downwards. Therefore, that relative position is just shrinking at a different pace. So when that relative position was shrinking at some different pace, I just need to get a different equation. But in this situation, the first I can fix the value for the first stone. That's going to be negative 240 because it has reached the edge surface. So that's going to be like negative 240. Then if I look at that equation, it should be clear. It looked like parabola open downwards, right? Therefore, the relative position between those two stone just shrink, and finally the relative position went to 0, right? And the graph was like parabola open downwards. When the time was equal to 12 seconds, both those stones reached the ground surface. Got it? So this is what you need to know regarding this question. Yeah, a little bit tricky. It has to be clear. Let's move to the next one. This question is relatively easy when compared to the graph sums that we have seen. Let me read it. A bullet loses 1 by n of its velocity passing through one plank. Okay, so when it passes through one of the wooden plank or whatever it is, it just loses 1 by n of its velocity. Okay, yeah, the number of such planks that are required to stop the bullet is, so how many number of plank is needed to stop the bullet? That's what I need to get over here. Got it? So here the relation is between the displacement that it is going to travel with respect to the plank and then the velocity, right? There isn't any detail regarding the time. So do not want to worry about the time. So I have to use this third kinematic equation. Okay. So here you've got like one of the plank. When it pierces through this one of the plank, it loses 1 by nth of its initial velocity with which it's gonna pierce. Okay. So the initial velocity, let us consider it to be u or v. When it comes out, it loses 1 by n of its velocity. So the remaining will be, so the final velocity v will be, or v dash will be equal to v minus v by n, isn't it? Initial velocity minus the velocity that got lost. That will give me the final velocity. Okay, so this will be my final velocity. So to get the equation, so the equation that I'm going to choose over here is v square minus u square, which will be equal to 2as. So let me consider the s as the distance of the plank, which I'll call it as d, whatever it is. I'll call it as d in this case. Okay, so d is nothing but the distance of this plank. So this is just a data that I've given you like an extra one for solving it. It could be s also, whatever it is. So next solving is final velocity. What will be its final velocity? V minus v by n the whole square minus the initial velocity, that will be like v square, that will be equal to 2a and then the d, right? Yes, so this is the condition. Let me solve this one a little bit extra. So if I do solve this one, you would have got v square plus v by n the whole square minus 2ab, isn't it? 2 v square divided by n. Okay, negative v square, that will give you 2ad, right? So here plus v square and negative v square, these two stuff will get cancelled out. Yeah, and then you will be left with yeah, that's right. So then you will be left with v square minus 2 v square divided by n square. Okay, minus 2 v square divided by n, that will give you 2ad. Okay, so 2ad, right? Yeah, it has to be fine. Then I just need to find the number of such planks that is needed. So I just need to get how many number of planks is needed to stop this bullet. That's what I need to get, right? So the number of planks that I need, let me consider it as capital N. So the number of planks that was needed, let me consider it as like capital N. So if I have to generate the next equation, that will be the final velocity. In that situation, the final velocity has to be 0 and the initial velocity will be this v. But the final velocity was 0. Instead of d, I'll have to substitute n number of planks multiplied by d. Okay, so that will give me the total distance that it actually need to travel so that that bullet comes to rest. Okay, so here when it passes through only one of the plank, this will be the equation. when it passes through n number of required planks so that the velocity becomes 0, that will be the second equation. Once I generate these two equations using the third kinematic equation, just solve it, you'll get the answer. Fine. It has to be clear. So let me do the solving. So if I do the solving, you'll get you would have got something like this. The final velocity should be equal to 0 minus the initial velocity, which is going to be the v square. That should give you, yeah, that should give you 2a n d, isn't it? 2a capital N d, right? So this is the final, this is the other one equation. So let me consider this is like equation 2. Let me consider this one as equation 1. So 2 divided by 1 will give you, should give you the answer, right? So 2 right hand side was like 2a capital ND divided by 2AD, okay, which will give you negative v square. That will be in the numerator. Same way in the denominator you would have got, let me factor out v square. So if you do factor out that one, you would have got 1 by n square, 1 by n square minus 2 by n, isn't it? Okay, so let me cancel this thing. 2AD, 2AD, okay. Same way here, v square will get cancelled out. Just solve this one, you'll get the answer. You got one negative sign over there, right? So you have to be careful with the negative sign. Yeah, fine. Yes. So capital N will be equal to negative 1 divided by this entire term. So this term is going to be n minus 2 divided by n cube, right? N, yeah, no, n minus 2 n square. Yes, n minus 2 n square divided by n cube. N minus 2 n square divided by n cube. That's going to get you negative of n cube divided by, let me factor out this n. So you would have got like 1 minus 2n, right? So these two stuff will get cancelled out. This will become square. This will become n. So if I do multiply that negative sign into it, you would have got n square divided by 2n minus 1. Yeah, n square divided by 2n minus 1 will be my answer. N square divided by 2n minus 1. Yes, yes, absolutely. So the answer over here is n square divided by 2n minus 1, which is going to be option 1, right? So you should be clear with this question. So even in this question is tricky. It's not an easy one either. So in this question, what they've given is like first condition and a hidden second condition. The first condition was like when it passes through one of the plank, it loses 1 by n of its velocity, right? So that from that itself, you'll get an idea. I'll have to use the third kinematic equation because they haven't given anything related to the time. So the distance of the plank is going to be constant. With the second case, they have given us it is going to pass through cap n number of planks so that it's going to get stopped. So that's the hidden. So I just need to stop the bullet. If I have to stop the bullet, how many planks are needed? So that's the second condition. So now I'm just ready to formulate two different kinematic equation. So once you get that two different kinematic equation, just do the ratio solving, you'll end up getting the answer, right? So this is what you need to know regarding this question. You shouldn't have any doubt in this question. So you should be clear with all the 8 sums that we have seen in this session. See, these 8 sums are tricky. It had different pattern of solving into it. We had a different approach of graphical thinking. Okay, so all the 8 sums aren't like something that's repetitive. Okay, so it had uniqueness to it. It was different. It was tough. Okay. So you should get through all these different pattern of mathematical solving and the thinking into it. So that is one. In the examination hall, you will be able to get that idea very quick. Okay, fine. Got it? Yeah, in the session, all the sums that we did see had different thinking. It was tough. It was competitive. Okay. So this is how JEE examination will be. As I've already told you, the concepts are going to be same with respect to NEET and then the JEE because physics is just the same. But the point is you need to have like different critical thinking to solve JEE sums. That's what it is needed. Fine. So practice all these 8 sums, get a different intuition and thinking behind those sums. Okay. So with that understanding behind it, you will be able to solve much more complex sums, right? Fine. It has to be clear. All the sums, you shouldn't have any doubt in those questions that we have seen. Fine. With this, the video is completed. Bye.